Kevin Rohlwing, quien es el vicepresidente senior de entrenamiento para Tire Industry Association. Comenzó en el negocio de los neumáticos hace más de 36 años como técnico en el concesionario de su familia en Elgin, Illinois, donde también trabajó como vendedor y gerente de servicios. Kevin creó y produjo los programas de capacitación y certificación de la Asociación para Técnicos de Servicio de Llantas para Pasajeros, Camionetas, Camiones Medianos, Excavadoras, Granjas e Industrias, que han formado a más de 140,000 técnicos desde el año 1997. Hoy nos va a hablar sobre el entrenamiento de seguridad del servicio de neumáticos. Démosle un fuerte aplauso a Kevin Rohlwing.
Yo quiero informarle a ustedes que la organización en la cual pertenece Kevin se dedica a ofrecer a nosotros, las empresas de neumáticos y llantas, unos entrenamientos que realmente no tienen valor. Yo les sugiero, ellos tienen un booth aquí, que los visiten, que se hagan miembros de la asociación. Ellos tienen diferentes misiones a diferentes países y le ahorran dinero, le ahorran la salud de los empleados y cómo trabajar mejor en sus negocios.
Thank you. Good afternoon. My name is Kevin Rohlwing, and I am the Senior Vice President of Training for the Tire Industry Association. And what I'm going to talk about today is tire service safety. One of the things that you'll notice here on the slide is right here, so make sure you hit the right buttons. Tire safety starts here. And that's TIA's slogan. That's what our mission is primarily about, is to promote tire safety, and specifically for the technicians, for the fitters, for the guys that are out there actually doing the work. We are an international trade association that represents all segments of the industry. We're based outside Washington, D.C. in Bowie, Maryland. We have over 10,000 members, and right now we're right around 150,000 technicians that have been trained or certified since 1997. So we've been doing this for a long time. I've been doing this for a long time, and what we're trying to do is raise awareness in the industry so that shop owners and fleets understand the risks. And I think that's probably the number one goal that I have for every class that I teach, every program that I write, is what are the risks? What are the dangers? And to put it very bluntly, when I'm teaching a class full of technicians, I'm basically going to tell them, this is how you're going to die. I mean, and it's very, very blatant, very blunt, but very direct, because I want them to understand those hazards. They have to know what are the consequences of me not doing it correctly. So that's really what we want to talk about. So again, that tire safety starts here kind of reflects our core mission. We have training programs for automotive, commercial, earthmover, farm, and industrial. Our commercial truck tire and our earthmover programs are translated into Spanish. We do have a bilingual instructor that can do Spanish classes pretty much anywhere that needs to be done. But again, for the actual materials themselves, the Spanish are restricted to the commercial and the earthmover. And then we have some consumer education videos as well that we have out there on a wide variety of topics for tire maintenance. This is some statistics that we put together, and from 2010 to 2014, we monitored all of the accidents, all of the fatalities in the U.S. And what we found was these are the three key areas where a technician is going to be fatally injured. Okay, so if you're a technician or a fitter that's putting tires on rims and rims on vehicles, these are the three ways that you're most likely to be killed. First and foremost, from the tire side of it, of course, because we are tire dealers, is a separation. And a separation would be defined as a split rim or a multi-piece rim that comes apart. It could be a tire that separates and releases the air. In a truck tire, we call that a zipper rupture. And it can be in other ways, broken beads, sidewall ruptures, anything like that. That's really what your separations are. Your jacking and lifting accidents, obviously, are lifting the vehicle. And what we see here is a very high number of fatalities in the fleet and the other category. This category here, this is the automotive service business. Okay, it's not really a tire dealer. It's a company that's fixing cars and maintaining cars. And as you can see, 82 people over that 4-year period died because the vehicle fell on them. I mean, it could have been anything from a car to a bus to a piece of equipment. But quite logically, when you're working underneath a piece of heavy equipment and it falls on you, you're probably going to die. So, that's really a major factor for us in terms of the training that we do. So we do that. And finally, this last category here is what we call the rollover. And the rollover is a technician is working under the vehicle and someone jumps into the driver's seat and drives away while the technician is still under the vehicle. And much like a vehicle falling on you with jacking and lifting, if you're working under the vehicle and someone gets in the driver's seat and drives away and drives over the top of you, you're probably going to die. So these are the 3 areas that we've identified in terms of fatalities related to tire, wheel, and vehicle service. These are the US statistics, again, from 2010 to 2014. So what I want to talk about first is, again, these separations, because as the tire industry, these probably affect us most directly. Because again, every time you inflate a tire, every time a technician inflates a tire, they're arming the bomb. Okay, the tire without air has no energy, so there's minimal risk. But as soon as you inflate that tire, as soon as you pressurize that tire, you're creating energy. And that energy is power, and that power, if it's released, can be catastrophic. And what we're talking about here again are those multi-piece, the 10-120s or the 20 and the 22, the 24-inch tube type assemblies on multi-piece rims where the components separate and results in some kind of, it can also be an earth mover or industrial areas as well. Anytime you have a multi-piece rim and those components come apart under pressure, there's tremendous explosive force and energy that really can cause serious injuries. And then we have the single piece, and what we're talking about primarily right here is a steel radial truck tire that experiences what's called a zipper rupture. And you're going to see one in a minute, what that looks like. And this is where the radial truck tire is run underinflated for an extended period of time, and the overflexing of the sidewalls weakens the steel cords in the flex area, which results in a spontaneous release of compressed air. So the key to this whole thing is what we call trajectory. And trajectory is basically, where is the air going to go? Where are the parts going to go? And how do I stay out of those areas? Okay, so let's see if this is an example of trajectory right here. Okay, that is air. That's all that is. There's no parts, there's no wheel components. That's just pressurized air being released from the sidewall, and the tire's in the cage. Here again, watching these tires blow up. These are all zipper ruptures. These are circumferential ruptures. Notice that when the tire is in the cage, it stays contained. The tire doesn't become a projectile. It's just the air. So what we're trying to focus on with trajectory, and this doesn't matter if it's a truck tire or a car tire or a farm tire or an earth mover tire. What I always tell students is real simple. Don't stand where you can read the sidewalk. Okay? This is an example right here of what happens when you weld on a rim with an inflated tire on the rim. Okay, you can see the little temperature gauge right there. There's actually a fire burning inside that tire until that moment right there. And what happens is that tire, the fire starts inside the tire, it creates pressure, and as you can see, the explosion is quite catastrophic. And again, it all comes to the point where the technician is standing in the trajectory. So what we want to talk about is tire inflation. What can we do to protect ourselves from these types of injuries. And it starts with a clip-on air chuck. Every tire should be inflated with a device that has a clip-on air chuck. And a clip-on air chuck is just something that temporarily attaches itself to the valve stem so I don't have to hold it. Okay? And if a technician has to take an air hose and physically hold it onto the valve stem when they're inflating the tire, they're in the trajectory, and if anything goes wrong and they're in the wrong spot, they're going to be in a lot of trouble. The risk of a serious or fatal injury is significantly more. Okay, and then we have what's called an inline valve with a gauge right here. And again, this allows the technician to stand outside the trajectory and add air to the tire. And then when you release the lever, the little gauge pops out that tells you how much air is inside the tire. Again, minimizing the amount of time that you have to spend in that trajectory zone. So I'm not standing in front of the tire while I'm inflating it. I'm not constantly walking into the trajectory to check the inflation pressure. I've got these tools that keep me out of that trajectory zone, that keep me away from that sidewall, so that while I'm inflating the tire, I'm safe. And you know, what we always tell people and our students is, you know, from a U.S. perspective, these are OSHA requirements. This is federal law. For truck tires in the U.S., this isn't an option for us, for our members and for our dealers in the U.S. It may not be law everywhere else, but we still want to make sure that everybody's aware of the fact that these are two key components of every tire inflation device that have a direct impact on safety. This is going to determine if you're going to die or not if the tire does explode. Okay, and then we have what's called a restraining device and also a safety cage. And this prevents everything from coming apart and prevents things from being thrown outside the zone, if you will. And the bottom photo right there is what we call a trajectory. And that kind of gives you an idea of where the air is going to go and where the tire parts are going to go if that were to separate. And what we tell our students, what we tell the technicians that we teach is this: if you're using a clip-on air chuck and you're using an inline valve with a gauge and you've got a tire inside a restraining device and you're standing outside the trajectory and the tire blows up, you change your shorts and you go back to work. Okay? Now, if you don't use the impact, if you don't use that clip-on chuck and you don't use that inflation device and the tire isn't inside a restraining device and you are inside that trajectory when the tire blows up, it's just a matter of chance whether or not you walk away or not. If you're in the right place, maybe you walk away. If you're in the wrong place, you know, your family gets the phone call that you know you've died in the course of servicing a tire. And in some cases, lightning strikes. But I can't tell you that doing this at the association and the training level for 22 years, that I can tell you the number of accidents that occur when all of these things are followed is less than 1%. It's a very, very small number of accidents that occur when the clip-on chuck and the inline valve and the safety cage and the trajectory, when all that's followed, the chances of an injury are very small. And everything you take out of that, the chances just keep going up. Okay, so as far as inflation goes, those are the key things that we want to talk about. So now let's talk about the jacking and the lifting side of it, because again, this from the fleet side, from the automotive service side, is by far the number one risk for a fatality. 55% of all the accidents were vehicle lifting. You know, again, the vehicle falls on you. You're working under it, and the vehicle falls on you, it's not going to work out well. I mean, it usually ends in a fatality. In most of these accidents, the jack fails or it slips out from under the vehicle. I mean, it's real simple. And what we're looking at again is those fleet and the automotive repair shops are going to see the most of these. And what you're looking at right here is a couple of things. The first one, this top photo right here, is called shock loading. Shock loading happens when the technician lifts the vehicle and takes the jack stand and just kind of places it underneath the axle or the spring or the frame to act as a stop. so that if the jack fails, then they're assuming that the jack stand will catch the vehicle and prevent it from falling on the technician. They're not rated for that. Jack stands are not rated for shock loading, they're not designed for shock loading, and in many cases they fail as well. The proper way to do it, as you see on the bottom photo right there in a commercial truck, is jacks are lifting and support devices. That's what lift it up, that's all it does. The jack stands carry the load. You lift it with the jack, you place the jack stands underneath the support points, you lower the jack so that the vehicle is supported by the jack stands, and it's very safe when you follow that procedure. Okay? When you don't, then again, the chances of that fatality are going to increase, and it's a very risky situation for the technician. The thing to remember is this, and this is what I always tell my students. When you don't use jack stands, you're putting your life in the hands of a small plastic ring. Okay? Hydraulic jacks work very simple. There's a ram, there's a steel ram that goes up. You see that when the air goes in. At the bottom of that ram is this plastic seal or this silicone seal. And that's what contains all the hydraulic fluid when you pressurize it. Well, that plastic seal, that ring right there, that's what's carrying the load. And if that seal fails, and you don't have a jack stand supporting the load, and you're under it, you probably die. And I see this too often, where technicians just put the jack underneath the vehicle, and they jack it up in the air, and then they're underneath there working on it, and I mean, you're putting your life in the hands of a plastic ring. I'm not going to do that. I've changed a lot of tires in my lifetime, and I didn't always do things correctly, but I can tell you right now, you will never find me working underneath the vehicle with just a jack supporting the load. Because I am not putting my life in the hands of a plastic seal. It's just not going to happen. Now, if I've got it on a jack stand, it's fine. And the same goes for the automotive side of it, whether it's a lift. There are mechanical locks on those lifts. If the vehicle is lifted up and the mechanical locks are engaged, it can't fall. And many years ago, I was watching one of the weather channels during a hurricane, and they were talking about all the devastation in a country, and I saw shops where all of the walls were gone and the roof was gone and everything was gone, and here's this car sitting up on a lift. And it was obviously in the right place, and I'm assuming that it was locked out. And I jokingly say it, but I'm not joking when I say, if you properly lift the vehicle, it'll survive a hurricane. But if you don't, and something goes wrong, the seals fail, the cables break, anything else goes wrong, and you don't have that load mechanically locked up, whether it's the mechanical locks on a two-post lift or a jack stand, gravity takes over. And if you're underneath the vehicle, or if a technician's underneath the vehicle, they're probably not going to walk away from that. So on the jacking and lifting side of it, again, we're emphasizing that you always use a jack and a jack stand, or if it's an above ground two-post lift or an in-ground lift, that you engage the mechanical locks before you go underneath the vehicle. Don't ever go underneath the vehicle if that load is not somehow mechanically locked up. On the earth mover, large heavy equipment side of it, then we use cribbing, you use blocks. You put the blocks to assist the jack. The jack stands are pretty heavy, so they're a little hard to be on the mobile side. But you can arrange the blocks, whether it's the composite or the oak. But again, there's always a secondary support device on the heavy equipment, and that is a key right there. And then finally, rollover. Rollover again it's a very big problem on the fleet side. This is a real big issue for trucking fleets and trucking companies when the technician is working underneath the vehicle and somebody just hops in the seat and drives away. And you're underneath there. And I had an accident up in northern Canada once where a technician, the vehicle was outside running, and we believe the technician left a tool underneath the vehicle, and he went to retrieve it. And just by fate, the moment that he went underneath the vehicle to pick up whatever he was getting, the driver hopped in the seat and drove away. And it was a tri-axle truck. So the driver felt the ba-dump, 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 ba-dump. and was kind of like, what was that? And he stopped the truck and got out and saw this gentleman laying on the ground, and he had driven over, and as horrible as he drove over his head, because he was trying to get out from underneath the vehicle as the vehicle pulled away, and the vehicle drove over his head 3 axes, and he died. You know, so what we're looking for right here is what we call lockout tagout. And lockout tagout is all about communication. Always making sure that if somebody gets behind the wheel of the vehicle that's being serviced, or the machine that's being serviced, or whatever it is, if there's a possibility that someone is working underneath that vehicle, that there's a communication device in place in that driver's seat to warn that person. And what we're looking at right here are a couple of different things. And if you were here years ago when Matt White was here, Matt is my director of tire service, does a great job. He's an amazing trainer. And he's been kind of collecting all of these different lockout tagout devices over the year. And you see a couple of them right here. This top one up here, this is a cable that loops between the steering wheel and the handle on the inside of the truck. And then it's got a lock that kind of connects the cable. And then he's got his own tag that has his name and his picture and his phone number on that tag. So if he's working on this truck and the driver comes up and opens up the door and wants to drive away, first of all, he's got to crawl over the cable. He's not going to be able to drive the truck because the cable keeps the steering wheel from moving very far. And secondly, there's a tag there that identifies him, his picture, his name, and his phone number. So that person can then look at it and go, okay, who is this guy? I don't see him, but his phone number's on there. I'll call him and find out what's going on. Because it might not be that he's working underneath the vehicle. It might be that the vehicle can't be moved. It could be something mechanical. There could be a safety issue with that vehicle that it can't be moved, so you can't have that as well. Then we have this is a steering wheel cover that you put over the steering wheel, and then you have a little locking device with it as well. And again, the key of the lockout tagout is that the lock, okay, has one key. There's one key. In a mining situation, if you ever work on a mine site, you'll see this little piece down here has 6 holes in it, because every technician that's working on that piece of equipment has their own lock. So if there are 6 people working on that piece of machinery, there are 6 locks on that device with 6 separate unique keys, so that the vehicle doesn't move until all 6 technicians have removed their locks. And again, this is about communication. I'm working on this vehicle, don't move it. And that's why we're emphasizing lockout tagout, to prevent these rollover accidents. So when we talk about tire service safety and kind of the things that we do at TIA, you know, on the separation side of it, they can be prevented. And it really is hard for me to investigate these fatal accidents where people are killed and it's preventable. It should have never happened. You know, if they had a clip-on air chuck, then they wouldn't have had to hold that air hose onto the valve stem. If they had an inline valve with a pressure gauge, then they wouldn't have to go up there and check the air pressure. And most importantly, if the tire was in a restraining device, then it's not going to fly out of the way. And you know, one of the things that I could point out is, if you remember back to the video that I showed before, the assembly never left the frame. The tire inside the cage never left the frame of the camera. And you can take like a 3-foot radius. You put a tire inside of the cage and draw a 3-foot radius. If this is the cage right here, you've got a 3-foot radius around this cage, that everything is going to stay in that radius. And as long as you're outside that radius, you're not going to get hit by the cage of the tire. And as long as you're outside of the trajectory, you won't get hit by the air. And again, like I said before, the best place to stand when inflating any tire is even with the tread. All right? If this is the cage and the tire goes in the cage this way, I'm standing in the trajectory. This, I inflate the tire out here and the tire blows up. What do? I change my shorts, I go back to work. I'm standing here and the tire blows up. My wife gets the phone call. So it's a very, very specific guideline that should be followed every time. I do this when I'm inflating bicycle tires, when I'm inflating tires on my car. If you can read the sidewall while you're inflating the tire, you're in the wrong spot. You should never be able to read the sidewall of the tire when you're inflating it. Always be even with the tread. Okay, on the jacking and lifting, very simple. Jacks lift, jack stands support. Mechanically locked out, that's the key. There has to be a mechanical lockout. Don't rely on that little plastic seal to hold the load. Most of those accidents that we reported in that 4-year period right there, almost every single one of them, jack failed. Truck slipped off the jack, vehicle slipped off the jack, vehicle slipped off the lift. All of them preventable if they had been locked out, if there had been jack stands, if the technician had followed the procedures for jacking and lifting, whatever it was, it's unlikely that accident would have happened. And then finally, on the rollover accidents, it's lockout tagout. I mean, I can't stress enough how important it is that there's some form of communication to anybody that could possibly get in that vehicle and warn them that it's being worked on. You know, whether it's a sign or it's a cable or it's a lock, whatever you have to do, but there needs to be something that communicates to the driver that this vehicle is being worked on by this individual, and it cannot be moved until that device is removed. And then the technician is going to protect themselves from that type of accident. So as far as TIA goes and what we do, again, we have programs for automotive, commercial, earth mover, farm ag, industrial. We have, it's all technician training. It's not designed to do anything else. We're not trying to sell tires or anything else. We're just sticking to the service. How do you service the tires? Again, the commercial and the earth mover programs are in Spanish, so you can get those in Spanish if you'd like. We do have an online platform that's only in English right now. And then finally, this last point right here, and I know that Mac's been down to a few places in Central and South America, and I actually have a technician, I have an instructor who is bilingual and can teach in Spanish or English. We do customized training outside the U.S. as well, and that will be hands-on, where we'll actually bring our instructor will come to wherever location you're at, and they will actually do the training at your location with your technicians, showing them how to use the proper tools and equipment to service tires safely. So, again, from the training and certification side of it, we're about 135, 150 right now. We have looked at some Spanish translations. I've learned a lot about Spanish in that there are different types of Spanish, and we're still learning that, but we're working on it, and we do have some plans to look for it, but we do see the need for Spanish translations, and we're heading in that direction. So, again, tire safety starts here. It starts with the right procedures, it starts with the right tools, and it starts with technicians understanding the risks. So with that, Gus, as always, thank you. Thank you very much. Have a great show. Peace out.